Welcome to my tutorial on how to add support for native iOS alert views to our base plugin. If you need a refresher on the base iOS plugin for Unity, then please see the first tutorial in this series. As with the previous tutorial, this one also assumes a reasonable level of familiarity with XCode, Unity, C# and Objective-C. While the iOS functions we'll use here have been marked as deprecated as of iOS 8, Unity still uses iOS 7 by default, so we're still going to use UI AlertView for this example. I'll show you how to use the more powerful and versatile UI Alert controller in another video. So let's switch to the previously built project and open MyPluginMM so we can add our new Objective-C code. Double-click the MyPlugin file and it will open up in XCode. The first thing we're going to do is extend our import statements to include uikit/uikit.h. Now we're going to define a special typedef, which we're going to call int_callback. This will be used to call program code in C# from Objective-C when the alert view receives user input. We're going to use this plugin as the UI alert view delegate, so we need to mark this object as conforming to the UI alert view protocol. In our interface declaration, we're going to add a variable of type int_callback that will be used to store the callback function reference that is passed when the alert view is created. When we're passing parameters between C# and Objective-C, we need to marshal the variables and convert them into the correct format for each language. As we'll be doing this quite frequently, it makes sense to add a function that will manage this conversion. We're going to add a class static function called createNSString, which will expect a pointer to a C-style string and return a correctly formatted and allocated NS string from that. This can be done by taking advantage of the built-in NSString function, string with UTF-8 string, but we'll also check to make sure the pass string is not null, otherwise we'll create an empty NS string. Now we're ready to add the actual createAlert dialog method to our plugin object. This method will require an array of strings, a count of strings in that array, and a callback function that will be triggered when the user taps an alert button on the alert view. First, let us convert the C-style array of strings into an NS array of NS strings. We'll do this by iterating over the array of C strings, and if the string has a length greater than 0, then we'll add it to our NS array as an NS string. Let's update the string count variable with the number of strings that are now in our NS array. Now we can create the actual alert view using our prepared NS array of strings and using our plugin object as the delegate. An alert view requires a minimum of 3 strings, and the strings passed in the array are used in the order of the title, the message, and the default button caption. Any strings in the array that are in excess of these 3 will be added to the alert view as extra buttons. Now, set our alert callback variable to the callback function reference passed into this method. Finally, show the newly created alert dialog. We need to add one more method to our object, and this method will match the protocol method AlertView clicked button at index. This method was called when the alert view receives user input and forwards it to its delegate. Our version of this method will simply print out some debug text and then call the previously set alert callback method with the index of the button tapped. That's our object updated with the createAlert dialog method and required delegate method for the alert view. However, we still need to add an access function that will allow C# to call into our plugin method. We're going to add a function, iOS createNativeAlert, that will expect the same variables as our plugin method. This will simply pass the input variables directly to our plugin method using the shared instance reference. That completes our modifications to the native iOS plugin module. Now we need to add our C# code. We will switch back to Unity and double-click the plugin test file in our scripts folder. Let's remove the test code from our previous tutorial as we don't need to spam the debug console log anymore. Remove the code in the update method and the frame counter variable. We're going to define a delegate that matches up with the delegate used in the iOS plugin. We will call this int_callback, and it will take an integer value as a parameter. Now create a reference to our iOS function that we created in our plugin in the C wrapper area. As before, this will match the name and the parameters for the iOS function. Let's create our callback function that will be called by Objective-C when the user taps on an alert view button. This function must be marked as static as it will be called from Objective-C code and must match the signature of the callback delegate that we've already defined. For now, let's just print the index of the button tapped to the debug console window. We need to mark this function with a special attribute that lets Unity know it will be called from unmanaged code, or in this case, our ObjectiveC code. With that done, we can now create the C# function that we will use when we want to show a native alert dialog. This function will expect an array of strings, which we will pass directly to the iOS function. We will do a check just to make sure at least 3 strings have been passed. As before, we will make sure we're also running on the iPhone player before we call the native code. To call the native code, we need to pass the string array, the number of strings in the array, and the native alert handler that will be called when the user taps the button in the alert view. The last thing we need to do is actually call the function to show the iOS alert. We will do this with a coroutine that will wait for a random amount of time before displaying the alert view. For this, we'll use 4 test strings that we use to build the alert view. With all these changes completed, we are now ready to build the iOS project. Press Command B or select Build and Run from the File menu. Once the build is complete, the project will open up XCode, and that build process will also start automatically. When XCode finishes building, it will launch the app on the simulator device. After some seconds have elapsed, our alert view will pop up on the screen. As you can see, the Unity code is still running in the background, even though the alert has focus. If we tap the Other button, then the debug text will show the index of the button we tapped, 1, from both the iOS code and from the Unity C# code. So there we have it, a native iOS alert view being called by Unity C# code, and the index of the button the user taps being returned back from iOS code to our C# code. That's the end of this tutorial. I hope you enjoyed it and learned something. As always, if you have any questions, please leave them in the comments section below. You can follow me on Twitter and check out my blog for more programming snippets.